G11 Physics. So this is the EOT coverage. Let me share the screen. Yes. So this is the EOT coverage, general physics. Uh, if you see the EOT coverage for physics term 3, 2024 and 25, there are main chapters. One is simple harmonic motion, in which period, time period, frequency, okay, and simple pendulum. Then we have wave properties, types of waves, longitudinal transverse waves, and its behavior. And there is no light concept much in the exam. Okay, so very simple. Let's discuss each and every question one by one. Here, see, if you see first question, define periodic and quantities associated with it, and like period and amplitude. So here, this is a very simple question. Define the period and its time period, amplitude, all that. These are the properties actually. These are the properties of a periodic motion. Okay, so just simple here. Period means any object repeats its mean position to and fro is called as period. Regular intervals of time. Any object repeat its motion to and fro is called as period. Okay. Amplitude is the maximum displacement of the particle from its mean position. Here the second question, distinguish simple harmonic motion from other type of periodic motion. See, other type of periodic motion means periodic motion is what? It's a repeated motion. Any object which repeats, either it's to and fro, vibrating, all these are all the periodic motions. Like in a watch, the needle, minutes hand, either you can take minute hand, second hand, hour hand, it will repeat 12 to, again it will come back to 12. Again it will go again, it will make one circular rotation, it will earth rotation. This is a periodic motion. Simple harmonic motion means uh, if a force exerted on a spring, okay, the distance of the spring stretched or compressed from its equilibrium position is directly proportional. The relationship between the displacement and the force is directly proportional and negative. This is called as a simple harmonic motion. Now, when the simple harmonic motion taking place in which there exists a energy, okay, any object if experience force, definitely that force is stored as an energy. That energy is in potential energy or kinetic energy. So if it is in case of spring, it is a spring potential energy, elastic potential energy we call it as. So here the third question is from the spring elastic potential energy, half kx square. Okay, so this is one formula. There are sample questions on which you need to practice on the spring. They will give you the how much distance the spring is extended and its weighs how much weight is given, and find the Fl. Okay, so here the solution for the question. F is equals to minus kx. Right. So these are the I given sample questions over here. So with this you can practice, and there's a definite questions from the potential energy. Coming to the fourth question, again is from the time and force and extension graph. So this is the force and extension graph, the area of the graph which gives the force constant. Okay, because the force is taken on y-axis and displacement is taken on x-axis. So f by x will give you the force constant, that is the slope of the graph. Next, fifth question. This is again same spring based question, spring balanced question. So here the spring, when you pull a spring is attached to a rigid surface, and if you pull the uh, mass, kind of mass, that will be move forward and backward. So it repeats. It's in the periodic motion. At the same time, the spring has a stored energy that makes the block to move forward and backward by itself. Okay, up to a certain extent. So this is called as a spring potential energy. Okay. So here they're showing the kinetic energy, where which place it has maximum kinetic energy and maximum potential energy. The different positions they have shown here. See here in this case, when the object is rest, okay, potential energy is maximum in this one, in this position. Whereas the force is applied towards to here, the spring is pulling towards the rigid surface, then what happened? Kinetic energy and potential energy. See, look at here. So they are at the balance level. Potential and kinetic energy both are high. Whereas the object is moved forward with the reference point, okay, then what happened? The kinetic energy is maximum. Okay, so that was the force and spring block oscillator. Okay, spring oscillator. This is also same spring block oscillator, the different position at a different time, what the energy it possesses. Next, coming to the simple pendulum, this is also comes under the simple or periodic motion concept. Simple pendulum is also exhibit the periodic motion to and fro, which has a simple harmonic motion also. Okay, so simple pendulum is used to measure time period of the bob. Time period of the simple pendulum is comprises of a string, okay, and a metal bob attached with its end. So its formula is 2 pi square root of L by G. Time period is equals to 2 pi square root of L by G. There are a lot of questions in the MCQs, L and G and time period, second clock, second pendulum. All these questions will be rises on this part. Okay, so there are some related numericals on formula is equal to 2 pi square root of L by G. So in this question, if you see that the length of the pendulum, I'll just explain one problem. Length of the pendulum is 1 meter. G is not given. By default, we have to consider 9.8. Okay. So calculate the time period. By substituting the values in the respective positions, you can calculate them. Here also the fourth question, same as like that. Next, eighth question, if you see harmonic motion and its uses and consequences. So resonance means the two vibrating objects, the two simple harmonic motion object, or if any two objects are in resonance, means their frequency are equal. When their frequencies are equal, that is we called as a resonance. The two objects are in, if you see in any concert, the violin all are playing at the same phase, the same frequency, then what happened? They gives a chorus song. The music will come. It's a regular period of time. Okay. So resonance includes rocking a car to free it from a snow bank and jumping rhythmically on a trampoline or a diving board to go higher. Okay, so these are the examples for this. Okay, when forces are applied to a vibrating or oscillating object at time interval equal to the period of oscillations. Okay, that is about resonance. Next, coming to the ninth question, this is also about properties of the behavior of wave. I mean the wave behavior. Okay, page number 158, 159. Okay, in this one also they discuss about transverse wave, longitudinal wave. What is definitions? You have to be thorough with the definitions. So what is transverse wave? What is longitudinal wave? Where you observe the transverse and longitudinal wave? What is the examples for transverse and longitudinal wave? All these we have to discuss. Okay, so this is called as a transverse and longitudinal waves. Is it clear? Right. Next, coming to the this is periodic formula. F is equal to 1 by T, the formula for frequency. It's reciprocal of time period. From this also you can calculate the numericals. Frequency will given, time period is asking to calculate. Next, units of frequency, hertz, time period second. So you can write per second also the units for the frequency. Okay, so almost maximum all periodic motion and the wave properties, all the questions, very simple, very simple. And here comes the speed of the wave. So speed of the wave, actually speed, what is the speed generally in kinematics? Linear motion, k v is equals to d by t. V is equals to d by t. So d distance and t is time here, time. But here in wave properties and periodic motion, we will consider d as lambda. Lambda is the wavelength between the two positions in the wave, that is either consecutive crust or trough, okay, or compressions and rarefactions. Trough and crust will observe in the transverse wave, compressions and rarefactions will observe in the uh, longitudinal waves. Okay, so this is about the properties of the waves. So the formula from here comes V is equals to lambda f. V is equals to lambda f. Clear? F can be written as 1 by t. So lambda by t, distance by time. So here just the same concept is same, speed, distance by time. But here in waves we are taking lambda is the wavelength and t is the time period. So based on that questions we have based on that formula we have few example numericals. Is very important in the exam. Last year there is one question that a lady, a woman has screamed. So the sound reached to the cliff and drifted back. So what happened is an echo is formed. So what is the speed of the wave or sound, like that the question is given. So on that we have to calculate same kind of question here also. Okay, so then you need to calculate the using formula b is equals to 2d by lambda, 2d by t. Okay, and wave also they will give crust and trough distance, and time period will give. Based on that also you can calculate wavelength. Okay, so there are 2-3 questions are there. From based on this formula you can solve the equation. Next here, by using the wave equation, say wave equation, this is called as lambda wavelength. So here this is trough, that successive trough distance is called as wavelength. So from this also you can calculate V is equal to delta D by delta T or lambda by T. Okay, so this is the wave. So this wave we call it as transverse waves. Okay, crust and trough. As I mentioned that the distance between the 2 points is called as wavelength. Okay, so by this we have to calculate the wavelength. Is it clear, guys? Thank you so much. And coming to the 16th and 16th question and 17th and 19th. So term 3 completely MCQ. So there is no written questions. So try to understand maximum. And in case we will see if any written questions also come, maximum problems will come. And they will ask the comparison of the transverse and longitudinal wave. These are the written questions. Hopefully all are MCQs. Okay, so apply Hooke's law and relate the force extended on exerted on a spring with the stretch or compression of the spring. Calculate from a force extension graph for a spring, the slope as the spring constant and the area under the curve as the elastic potential energy of the spring. Okay, so here comes the page number 153 and 155. The question is given here. A spring stretches by 18 centimeter. Okay, 18 centimeter is the distance. Bag of potatoes weighing 56 Newton is the force. So F is given, X is given. X is in the centimeters, convert into meters. So we have to check very careful while you are calculating the numericals. All units are in the same format. Okay, then you can start substituting in the formula. F is equals to minus kx, and negative v shows the direction of the force opposite to the displacement. Okay, so by that you can calculate the k value, and finally you can calculate potential energy. So here we go, we saw F is equal to kx, so k we have to calculate, so work out and substitute in the potential energy form. Next comes to here, apply Hooke's law. Hooke's law related to um, a force simple harmonic motion, instant displacement of an oscillator, that instant. This is also a numerical question. In the numerical question, they gave spring constant K by observing Newton per meter is the units, 56 Newton per meter. How far will it stretch when a block weighing 18 Newton is hung from its end? Okay, so like that we need to calculate and challenge this question spring again, same like that. How far far means here distance, so we have to calculate. So by using the potential energy formula, U is equals to half kx square, you can use the formula k. how far means distance we have to calculate. So x keep one side and remaining parameters, remaining variables, stand it to the left side and make a formula in terms of x is equals to square root of 2u by k. So by that you can calculate using the formula x is equals square root of 2u by u is given, that is the potential uh, energy 48 joules, because we will cal energy measured in joules. So 48 joules, and k is the spring constant. Okay, so by substituting we'll get the answer. So here comes out. Yes. Next, coming to the here, there is a question like a pendulum. This is a pendulum. See, string which attached to the a weight or mass object. So we need to calculate the pendulum's location. What is the gravitational field at the pendulum location? So we have to calculate G. So if you see the formula, time period T is equals to pi by 2 pi into square root of L by G. By using this formula, L is given 36.9 centimeters, so convert into meter, and time period is given 1.22 seconds. So G, you take it 2 pi square L by T square. Substitute all the equations, you will get the G value. Next, here comes to the 18th question. The second question is about displacement and distance versus. So is asking about differentiate between the transverse and longitudinal wave. Transverse and longitudinal wave is what is the difference? Mainly it is longitudinal is vibrating particle always perpendicular to the direction of motion of the wave. Suppose wave is moving towards right side from left to right, the vibration of the particle for that plane will be perpendicular. Whereas longitudinal waves, the vibration of the particle will be plane, I mean parallel, along the line, along the plane, parallel. Okay, so just mode of vibration differs transverse and longitudinal. And examples for transverses are the electromagnetic waves, whereas longitudinal wave is sound waves. Okay, so this is about that 18th question. And coming to the last 19th question, this is a question which I discussed you. Miriam shouts towards a vertical cliff as shown in the figure 12. The echo is heard after 2.75 seconds. Time is given. Echo. Echo means the sound has been traveled from the Miriam towards the cliff as well as reflect back and bouncing back to Miriam's ear. Okay, she heard that sound in echo. Okay, so it's the travel distance is 2 times here, not 1 time. Okay, be careful. So what is the speed and all that you have to calculate. Okay, period of the rate. So the formula is v is equal to 2d by t, because the sound traveled 2 times. Okay, so thank you so much. This is about the EOT coverage, and I wish you good luck. If anything, any doubts, please feel free to ask me. That's about. Thank you so much. Thank you. All the best. Okay. So please concentrate mainly on time period, uh, simple harmonic motion, wave behavior, wave properties, and formulas. Okay. If you're thorough with the formulas, then you can calculate maximum all the numericals. Mainly the formulas are: number one, frequency f is equals to 1 over t, and v is equals to lambda f. V is equals to lambda f. Next is potential energy of kx square, and spring constant force, spring balance forces F is equals to minus kx. Okay, so these are the formulas. Okay, guys, thank you so much. Bye bye.